This
woman who
conference will now
tells
be
us that
recorded.
it's being recorded. And now I'm going to welcome uh, Dr. Vincent Lanjou from CNES to tell us more about the coastal digital twin project.
Thank you, Mary. So I will make the presentation with Laura from NASA, because as you will see, it's a project in collaboration between CNES, NASA, and NOAA. And you have the contact points on the first slide. So myself, Laura, and Sean Helfrich on NOAA side. So SCOast DT is a combination of SCO, SCO for Space for Climate Observatory, COAST, and DT for Digital Twin. And I will maybe first introduce you what is the Space for Climate Observatory, because I don't know what you know about that, and then we will move to the project itself. So the Space for Climate Observatory, it's an international alliance with more or less 50 signatories. Most of them are International Space Agency. It's a cooperation framework which is there to develop projects in cooperation and to provide operational tools thanks to SCO projects to studies and help decision makers to adapt to climate change. So we are not talking about measurement of the carbon dioxide at a global scale. We are more talking about very specific use cases targeting at specific area, and the coast one is one of those. In collaboration between typically university, lab, and decision takers. So it's a big network. There's a website which is available. You can have a look at the project. And to be selected as a project, so there is one call per year. Today, I think we have more or less 80 projects that have been accredited. Maybe half of them are active today. The typical duration of a project is 2 years. And so you have to be selected, you have to address the needs of end users within a given specific area that has been chosen accordingly. You have to, in the end, you have to propose an operational and practical software. Welcome, Sean, by the way. I just see the message from from Mary. You have to, of course, to use satellite data, but not only, because we realize now that to propose a good solution, generally you have to combine satellite data with some other kind of data, like, for example, socioeconomic data. If you want to estimate, I don't know, the risk, for example, you need to know where are the economic assets. We don't want to duplicate, so you can build on pre-operational research infrastructure, service or local data provision. And in the end, we want a good potential for extending. And hopefully what we are going to do with Coast will be a good demonstration for that. Just a few key figures. So 80 projects, I already said that. Yes, maybe this year there was, I think, 40 submissions and 10 projects have been accredited, and SCOast DT is one of those. Just to give you an overview of the map of all the projects. So initially, it has been initiated by France. So there are many projects in France, but it's expanding internationally. So we have this slide is for the last year. That's why the number of projects is not up to date. So it's now 80. But I encourage you to go to the website. Maybe we can see it. Do you see my screen there? No, okay, only sharing one. Okay, so go to the website and you will be able to navigate through the award map with all the projects and filter them as a function of the topic, and coast environment is one of this. And then I maybe hand over to Laura. Now we'll focus on the SCOast DT project and starting by maybe defining what is a digital twin. Go ahead, Laura.
Hey, good morning. Hopefully everybody can hear me. First, I just want to say congratulations on the selection to a VC for the CIAS community. That's a big step and great to see that the recognition for the coast. So I want to start on my end on what do we mean by a digital twin and our system digital twin. There's a lot of words out there around digital twin, and everybody has a slightly different definition. So I just want to touch briefly on what we are talking about when we say we're doing a coastline or a coastal zone digital twin. So we really look at it in three components. The first one is the digital replica. So the what is right now, and this is an integration of all the current states, but it includes the continuous observation. So it's not just a representation of what was, but as just as in the human body, every time you take a breath or get a cold or grow over a year or 2 years, that system needs to be continuously updated. And so that continuous observations, the continuous knowledge, and to replicate where you are currently. So a digital replica brings in the multiple observation and continuously updates over time. The next component we talk about is the what next. So this is, we've got the digital replica, but then looking forward, let's look at the forecast. And this could be at multiple scales. This could be at the seasonal, the subseasonal, or it could be at the climate scale. So really forecasting what next, and continuously updating that digital replica as well, right? So the forecasting is the integrated picture of how things will evolve. And that's the interconnectedness of the multiple systems. And this is at the physical and the temporal scales. So understanding multiple ranges there. The third component we talk about, so we have the what now, we have the what next when we talk about the forecasting, and then we want to bring in the what if. So this is where we can bring in a perturbation to the system, right? So what if something were to change, and how can we look at that impact assessment? So, and how will things evolve under very hypothetical situations? And so these what if scenarios could be things within our control, so human-driven changes. So if we look at a coastline, that could be a beach renourishment, or it could be a barrier of some form. But it could also be an environmental change that maybe is outside our control. What if there was something significant to happen to the system, or different storm regimes to come in, or different climate models that we don't anticipate? So when we talk about the digital twin, overall, again, it's three components: the digital replica, that forecasting for the what next component, and then the third is that what if component. So we can really turn different knobs to see that what would happen within that interconnected system. But we also recognize this is a huge task, right? It's not just run a model and see what it spits out. There's a lot of data involved. So this will require different technologies to bring this in. And this is where this project is really trying to focus, is bringing in the technology to make this capable. So I'm sure many of you can talk about 5 to 10 to 20 different models that could potentially fit, but how do we bring that together? So we really want to bring in the integrated prediction, analysis, and visualization so we can communicate what we're saying, but we also recognize that we're going to need to implement various different types of AI or surrogate modeling, and uncertainty quantification is going to be a big component of this. So these are all various components we talk about when we mean digital twin. I'll stop there. Vincent, if you want to go to the next slide. All right, and so how did we come together here? So some of the context here is that you see our partners are NASA, NOAA, and CNES, and we've got a strong background working together. We have an extensive historical collaboration, it's specifically in the coastline. So we look at SWAT that was just launched as a great collaboration. NASA, NOAA has worked for many years on looking at sea level rise. And then all three of us have really focused on a coastal zone digital twin grand vision. So it made sense to start bringing some of this together and working as a team to understand how we can do some of that cross-agency, that international partnership, because we all can say now that we're not going to make a change unless we're working together. So this was an opportunity where the three groups are coming together with a similar focus. So our goal here, really coming from, as I mentioned earlier, the focus here is on we know some of the science is starting to come together. How can we leverage the new technologies that are available to really scale this up and really bring all of these together? So we are putting together a framework and an architecture to bring the models and the data and these new technologies, and whether it's the surrogate modeling or some of the uncertainty quantification together, and look at how we can use coastal zone as a case study to test some of the new technology in the framework. But at the same time, we want to make sure we're addressing real issues. And I don't need to explain to all of you that this is one of the most pressing issues. We're already seeing impacts due to sea level rise and coastal change. Um, so at the end of this, we really want to be able to jointly define a digital twin architecture. And this is going to be modular. It's going to be extensible. That's the intent here. And it has to be interoperable. And we hear this a lot, but we really want to test it out in one of the most complex scenarios that we can. And again, we're going to exploit a real use case. So that's where we're looking to do a coastal zone. Vincent just introduced the idea of what the Space for Climate Observatory is. As of February, we have been announced as an official project and labeled as an official project, which means this really opens some doors to us as far as some of this international collaboration. All right, next slide.
Maybe that one is for me. Just a schematic view of the coastal zone, and just to remind you that remote sensing, I don't believe I need to convince a lot of people in that group, right? Because it's just a coast virtual constellation. But so it's a general slide just to remind us that remote sensing can give us a lot of information, up to date, precise on the coastal zone. So if we start on seaside, we can measure bathymetry, which is a key parameter to be able to make proper hydrodynamic simulation, very important for flooding modeling. Water level and quality, we just talked about SWOT, all the biological processes, and speaking about algae, for example, benthic mapping, and of course the sea state, which is very important if you want to estimate the risk. Moving towards the shoreline, so identifying and mapping the shoreline is an activity in itself. There is this very specific zone, the intertidal zone, which is very important because it's very dynamic, and we want to understand what's happening there. So it's also possible by observing the shoreline at different tide level to really map properly the intertidal zone. And then moving to the land, there we clearly we can map using in particular very high resolution satellite the topography in 3 dimensions, estimate the soil and land use, all the hydrology and ecological phenomena that occur there. Of course, this coastal area is really in between ocean and land by definition. And so technically, it has been mentioned by Laura, there's an interoperability subject to tackle there, because we will be constrained at the edge of the local digital twin by bigger digital twin of ocean and land. And so it's a very good case to work on federation and interoperability. Moving on, I don't know if it's for you, Laura, or me. I don't see the comments, in fact. Sorry.
We'll just go for it. And Sean, feel free to jump in as well. But I think for this, we really wanted to tackle the challenges from both the technical side of things, as well as address those coastal area challenges. So I've already kind of gone through this evolutionary framework that we talked about. And again, we recognize there's no one model fits all, right? So that's really the intent of having this evolutionary framework, to be able to bring in the various models that are appropriate for your specific region, your specific task at hand. So the big task is the architecture and the creation of the digital replica. And this involves that ingestion system, that registration of the various data, the storage or the caching of the products that are produced. So developing this digital replica. then be able to bring in the modeling and forecasting, which I touched on, and then again the system perturbations, and again those could be the environmental or human influenced. But the last thing I want to stress here on the technical challenges is being able to monitor the system, right? Understanding if there's a mismatch or if there's a component that's not working, a component of control, right? How can we make sure that we are it's coming together in the timing that we need to. So, or if there's data that is not available. And then the last piece there is that visualization. So if we can't communicate the results, if people can't understand it, it's not going to have the impact that we're looking for. So when we talk about a system, it's both the technical, but also that human interface. It's also the visualization. It's also the communication. But to do this, it's addressing the coastal challenges. And again, this is a use case so that we can bring it forward. So we want to address the diversity of coastal issues. We're going to go through some of our regions of interest in a few moments, and it's really trying to cover a diverse range of things. We want to be able to look at the past as well as the present so that we can get to the future, right? So we've got a long history of data sets, bring those in to understand those trends, and then look to the future, and that's where we can bring in some of the perturbations. And then again, the future projections, and into carrying over from that communication visualization line, make it available to both the scientific community, but also the general public or any different types of users. And we're looking through various personas and how to make sure that we're reaching through those different interest ranges. And we'll talk about some of our plans to get to that momentarily. Next slide. All right, so here's where we touch on our initial regions of interest, and we'll go through these more in depth. But we wanted to hit a range of interest, right? Like, so if we look at the East Coast versus Alaska, there's going to be very different technical challenges, coastal range challenges to that. So we wanted to be able to start with one, but make sure that we can, our framework is evolutionary enough, is interoperable enough, and modular enough that we can also address the issues that are happening in different types of coastal settings. Next. And so we hit on, and I should have mentioned this on the previous slide, but you saw some that were U.S. based and some that were French based, and that's based on our partnership here. We wanted to hit a little bit on both sides, but again, the ultimate goal is to make it accessible to any type of global community. But we're again working through these, and you see some of those international challenges. But one of the ones we're going to start with on the US is in the Hampton Roads region. And I should have put a US map on here, but this is the east coast of the US. And you can see Washington, D.C. Kind of up in the top left corner there. But there are significant challenges in the Hampton Roads region, and I actually think the SCOast Coast community is looking at the Chesapeake Bay region, so I think you're probably familiar with it. But we also recognize that there are a lot of significant challenges. Many people in this coastal region, the Norfolk Naval Station is here, which is the largest naval base in the world, so there are significant interest in understanding the flooding challenges that are happening here. And we also have the Port of Virginia, which is the third largest container port on the East Coast. So if we talk about supply chain and expanding out to the impacts beyond this immediate region, there's a definite interest here. So the Chesapeake Bay region faces significant challenges in urban flooding, but also the smaller graphic there is looking at the various the pollution in the Chesapeake Bay and some of what's happening from the runoff from fertilizers and so forth. So yeah, I see you have a pilot in Chesapeake Bay and also the Arctic region. So again, a lot of potential overlap and synergy here. So a lot of these pieces. Yeah, Sean, go ahead. I see your hand.
Yeah, I'm hoping my microphone is working.
Yep.
Can I get confirmation on that?
Yep. Yeah, we're good.
Okay. Just pointing out, Mary Beth, that this is going to be one of the areas that and one of the type of cases we're going to be looking to examine within Chesapeake. I think when we're building out our digital replica, we're looking to be able to have it on a broad Chesapeake Bay understanding or build out of the data necessary to be able to apply it for multiple types of applications and investigations that we'd like to be able to conduct. But the Hampton Roads area or this area of Virginia, at least from an urban flooding perspective, is one of the things we'll probably start with from an investigation standpoint.
Yeah, absolutely. Thanks, Sean. Go ahead. Okay, so I will continue on, and yeah, again, so we're going to look at various use cases, but again, we want to make sure that digital replica is able to answer multiple questions, not necessarily just the one. So yeah, you can go ahead to the next slide. We're also going to be looking at the Gulf Coast, and we know that there's significant issues there when we start looking at rapid land loss from the sediment distribution. We also know that with the rising sea levels and the lower river levels, we're seeing some saltwater intrusion, which is having some significant impacts on our local water supplies, as well as, you know, of course, the ecosystems, as we're seeing impacts from the salt there. And next, I think I'll just go to next slide for Vincent to talk about some of the challenges they are addressing in France.
Yes, so starting with the metropolitan France area, so we are going to study there the shoreline evolution at national scale, I would say. And that resonates a lot with recent studies by CEREMA. CEREMA is a public institution in charge of evaluating the risk in France. And what they said to us in this report that have just been released is that potentially 500,000 buildings could be impacted by shoreline evolution by the end of the century, which is of course a huge number, a main concern, I would say, and that would last probably decades to be able to properly adapt to that and to potentially move some people and buildings with time. So the goal there will be to first, what now? Establish how the coastline is evolving over recent decades thanks to satellite imagery. So it has been mentioned in a previous meeting, and I saw Erwin. No, he has just left. We have a code to determine the shoreline position as a function of using satellite optical images. So we will use that, applied it at the national scale, and map this coastline evolution over decades. And then, of course, we would like to determine if there are hotspots, could be accretion hotspots or erosion hotspots, and try to evaluate what is a type of risk and spatial distribution along the coastline. And speaking about projection and evolution with time, the question will be how will the dynamic of erosion and accretion around the coastline will continue to evolve, and of course to evaluate potential in some cases around some hotspots to evaluate if there are some cost-effective mitigation solutions. And where are the priorities in terms of population in assets. So we have the chance to have a lot of in situ measurement in France. So we'll be able to validate what we are doing with satellite data, having in mind that we would like to at some point extrapolate and extend our analysis at a more global scale. Okay, I think that's it for that one. So it's the biggest area that we have. So only speaking about shoreline there. Moving on to Africa, we are going to study the coastal lake in Nokoué in Benin. It's a lake, so it's a coastal lake, so connected to the ocean and also to a very large, in fact, watershed that typically span, I think, around 70% of the whole area of Benin. So there's a lot of issue, I would say, in that region. Okay, thank you, Mary, for your comment. So it's indeed, hopefully, a nice pilot region. So it's very complex and variable, right? There are some salinity intrusion, sorry. water quality that is very variable as a function of the river discharge that are connected to the lake. We have flooding problem with a huge amount of houses that could be destroyed, many people living in the surrounding, and it's a living resources for many peoples. There are also problems with the vegetation, with hyacinth, I'm not sure of the pronunciation, sorry, hyacinth seasonal expansion that could impact the livestock. So that's why it's a good region of interest. By the way, working with Lagos, which is a French lab close to CNES in Toulouse, actually, they deployed 30 in situ stations there. So once again, when working on a given area, we want to be able to validate what we are doing. So in that case, we have maybe 7 years of in situ data with C campaign around, and so we'll be able to cross-check that what we are doing is correct, and to evaluate, of course, the uncertainty of all the processing we are doing on satellite data. So what now? What do we want to study? Water level, quality, salinity. I already said that. Speaking about what next, one of the question doing some forecast will be clearly the flooding. If a given storm pass by, we want to be able to warn the people living in the surrounding, identify what part of the coastal lake will be impacted or not. And then on the long term, the balance may change because of sea level rise in terms of salinity intrusion, water quality. We can, for example, forecast storms that are more bigger storm. I don't know how to translate that in English, associated with the sea level rise. And the question will be to derive some indicators to support and integrate in the management of the lagoon. So that's our second use case. And the last one will be New Caledonia, because New Caledonia is representative of all the problems encountered on an island. So there are local problems. It's clearly highly exposed to cyclone and storms and to sea level rise. There's generally an atypical population density. For example, in Nouméa, I think that 70%, around 70% of the population lives there. I don't know if you see my mouse, sorry. Okay, and there's also a highly varied building type there. Some are in concrete, some other are some kind of wood and very light buildings that are not impacted the same way by a given storm or flooding event. And there are some technical problems too. For example, a scarcity of in situ data, because it's a huge area to be covered with sometimes few people. Basically, there's no in situ data in most of the cases. It could be difficult because of cloud in the optical range. When you see like that Google image with many clouds, it sounds that the average cloud coverage could be quite important, right? And so you need to handle large area sometimes for few people, and that's why we believe that remote sensing with global coverage can clearly support the analysis for this kind of specific region of interest. In New Caledonia, we identified that the big gap that need to be filled is the bathymetry measurements along the island, because we observed that only a few parts of the island is covered by high resolution bathymetry. And once again, if you want to be able to properly model the impact of a storm of sea level rise, we need to get this bathymetry in for the analysis. So one of the first things we're going to do is to try to derive bathymetry using remote sensing all along all along the New Caledonia coastline. So the main thing we want to, the main point we want to address in New Caledonia is really the problematic of coastal flooding, sea level rise impact, combination of storm and sea level rise, and see how this impact human and natural environment. They are starting in New Caledonia to move people because we know that some regions are already at risk, and so it's a huge effort to come in the next decades to properly anticipate what houses, what people have to be moved, in what priority, and we believe that such a digital twin of the whole island will be a very good support to decision takers to make this hard decision in the future. And I think that's it. We are now getting close to the end. I don't know, Laura, or maybe your support would like to conclude this.
My support doesn't quite know how to read that yet. But so in the bigger project, we are really just starting as far as our collaboration. However, there's a lot of components that are building up into this. So it's really the time to start bringing together from an interoperable standpoint. So a lot of the components have really been in the works for years, and some might even say decades, but if you go back to some of our observations. But we just kicked off the initial architectural workshop. We had that last week, actually. So Vincent and his partner came from France, and we met at NASA Goddard just last week. We had quite a few representatives there to really talk about what that architecture needs to look like. How do we really want to connect the user needs to some of this initial digital replica? Again, looking at that ingest system, looking at what are needed from a storage, monitoring, so forth, and bringing those together. So we're going through that now, looking, developed a couple white papers, and really going to kick off the project in the June-July timeframe to really technically start bringing these together. Sean, you want to add to that?
Yeah, just that one of the things in leaving the meeting, I guess, last week is at least of the couple of NOAA people that were there, we all were in agreement that we probably would like to be able to have a NOAA meeting among our not only the contributors that are known, but a lot of the contributors that are kind of unknown to us at this point. And making sure we're kind of bringing together a wide variety of people throughout the different line offices as potential contributors to this. And ensuring we're kind of building out a lot of the user applications, once again, that are they're each group is coming in with kind of their own understanding of potential applications where eh, but there's a lot that are also unknown to us. So we want to be able to make sure that groups like the National Marine Fisheries Service or NOS that may see a different application to this can utilize the same framework to try and build out and answer questions that they have and to be contributors early in the process.
Yeah, absolutely. And I think that's also why we're here today. We want to make sure that we're capturing the user needs and the understanding and the knowledge that's been built up for, again, years to decades, so that we can really bring forward the best framework possible.
A-
So we're just
And
getting going, and want to start building out that digital replica. But again, this group, all of the work that's been done in NOAA, and then towards the end of the calendar year, we're going to have the first user workshop. So we'll be able to kind of give a baseline demonstration of what our digital replica looks like, and really have the wide variety of folks there to give some feedback on exactly what Sean was just saying. Refine those needs, the data refinements, looking at latency, looking at the spatial temperature resolution, what's really going to be needed, how often does it need to be refreshed, that type of impact. So, a first rollout of the digital replica towards the end of the calendar year for refinement. from our French partners. They've got some fantastic bathymetry and shoreline tools that they're looking to open source and release again at the end of the calendar year. And then we'll continue towards the beginning of 25. We'll have that second user workshop where we'll have that improved digital replica, and then we'll really be, starting to develop and what's the right word? So after going back, after the first user workshop, we'll be developing that user interface and understand, how does that come together. So we'll demo that initial user interface at the second workshop and start bringing in that forecasting capability. And then, we really want to have by June-ish of 25, our first demonstration. And this would incorporate the digital replica, that what next component, and we would do somewhat of an example what if project, because we know that this is a huge undertaking. So we don't think we'll get there all in just 1 year, but we want to be able to get to an example, kind of a canned what if scenario for that demonstration in approximately 15 months. And then this will continue on for the next year, where we're really going to build out that digital replica. We're really going to build out that visualization communication component and get towards that user-driven what if scenarios. So this is the rough timeline, but we're undertaking this knowing that this is quite a task. This is a large undertaking. This is going to be a significant effort. But the more input and feedback we get on some of this, the stronger some of it will be. So open to questions from there. I think that was our last slide. Or Sean, if you want to add to it.
No.
Okay, and I see some hands.
Go ahead, Gada.
Okay, so thank you for the pretty nice presentation. So we have been really working on the digital replica and digital twinning. Probably know the European digital twin of the ocean is one of them. And I really like what you have mentioned, Vincent, that this is really, I mean, if you are looking at the coast, this is really the downscaling part, that you have to have the digital twin of the ocean to be able to say or downscale from there to the coast. My question is, so you are aware of that, and I think this is very nice to have this interlink, because then we are not reinventing the wheel every now and then. My question is specifically for the coast now. It's not only the water, but it's also the land interface and the hydrology. I heard that. However, I kind of miss on some of your use cases this link to the hydrology and the catchment hydrology. I'm not really sure if you are taking that into account in any of the use cases. So that was one question. The second question, yes, sorry. The second question, because it's very interesting. The second question is, how can you actually participate? Because there have been also other initiatives like Ocean Prediction, DCC. This is the Decade Collaborative Center, where I'm also part of. And there is the Coastal Resilience. This is also the DCC, which I'm part of. How can we actually, I don't know, collaborate or interact in order to enhance what we are doing? So really to strengthen this coastal replica, because this is the way forward. I know it is the way forward. But it's a huge effort. And if you can collaborate with other initiatives here and there, I think we can arrive to what we want to arrive to together. That's all.
Great. Thank you for your question first. I start by question one, and then we can address the second one. On collaboration, and well, the short answer is that we are there to promote what we are doing and to be able to establish contacts. So that's basically what we are doing. So in Nokwe, to answer to the first question, which is about hydrology, the full watershed will be modeled, in fact. So there's I think it's Symphony, the name of the model. We'll have a full model of the watershed at different with different resolution. I think, for example, the topography of the watershed is based on SRTM on the large scale, but close to Nokwe, we intend to make much more precise 3D topography description using a very high resolution digital elevation model derived from very high resolution optical images, typically at 1 meter. So that's going to be our first implementation. So yes, so in that specific case, I think hydrology is part of it. The river discharge will be modeled, the salt intrusion will be modeled too, and the balance between the circulation of water between the coastal lake and the ocean will be modeled. So this is the first question. On the second one, on the collaboration, I mean, we are there to discuss that, of course. We work globally under the umbrella of open science. So we really intend to deliver the data and the tools, most of them. So we intend to support the potential extension of this kind of analysis by providing the data and the tools. And we would be pleased to exchange with you in another forum if necessary, of course. And that's why we are there today, to inform you and to take a good contact person in other forum. Laura and Sean, feel free to complement if you like.
I think that's the hardest part, is really making connections and knowing. Actually, Laura Lorenzoni just reminded me of the Ditto effort. So how can we sync the Ditto effort, where we're talking to the larger scale ocean, to the coastal digital twin, right? So making those connections and just making knowing when to connect and where, I think, is the really important thing. So Sean brought up earlier the Coast Watch meeting. So we're going to make sure that we have work there so we can develop different partners there. But that's the crutch here, is knowing when and where to connect and how to best do that. But part of this is we want to make sure that we can be modular enough and interoperable enough so that it should be fairly easy to make some of those connections once we find those right points. But I think that's a really important part, and I appreciate you bringing that up, and we'd love to understand some of from your perspective, where those right points are.
Happy to help anytime.
And I'll just also add that, this is also hopefully interconnecting with lots of other digital twin efforts. And the ability to be able to bring those in a collaborative and synergistic way is something that might lead to more unique results as this continues to kind of build out. It's not just about building this for single purpose study and single purpose models. It's about being able to have this where, as I think it's kind of been mentioned, it's going to be modular and can interchange with other digital twins.
Totally agree. I think it's how to sustain what we are heading to build. This is really cannot be sustained by an individual. It has to be sustained in a collaboration. So,
yes, that's going to be the ultimate measure of success towards the end. Is did we build something that is a good start to something, but what is ultimately how that integrates with efforts and how it's utilized will really be kind of that ultimate deciding. Mary Beth, I see you're
Yes, I
want to
have
be able to get your question.
I have just two quick questions. First of all, so one of our roles is that we do have identified regional user communities, especially in our pilot regions. So I'm wondering what help can we give you with your user workshops? Shall we just advertise it? Is it open to everybody? Would you like access to our identified stakeholder lists? And then my follow-on question has to do with where does the digital twin sit, like the development space, when it's completed? Could that be something that sits within SCOast Coast or the SCOast Analytics Laboratory? Thank you.
Those are both great questions, and Sean or Vincent jump in. I think we're still scoping some of the workshops. We're still identifying the team, honestly, to be working through some of this. But definitely us kind of staying in contact and understanding your contact and your user working groups would be incredibly helpful. I know we've got a user base, but we'd love to expand that. The second component, you were asking about where this is going to be developed. So our initial development is going to be, of course, cloud-based. We're going to be working within the NASA Science Managed Cloud environment to begin. I've also chatted a little bit with, so Dave Borges is my former office mate. He's talked about the analytics lab a little bit, so kind of exploring what that could be. But we are starting in the Science Managed Cloud environment from NASA. But of course, the long-term home, as Sean was saying, that's going to be the ultimate marker of success, of how do we make sure that this is transitioned to something that is sustainable.
Great, thank you very much. We have just 1 minute left. Are there any other questions for any of our speakers? We will share their emails in case anybody would like to reach out to them offline as well. And if you know anybody who should see this, we'll be replaying it for the afternoon session. I'm also able to file share access to the private access link to the recording if you know of somebody who should see this. So thanks very much again to our speakers. And especially Vincent for coordinating the speakers and the presentation.
And Laura and Sean.
Yeah. Oh, and Laura.
It's okay.
Yes. Thank you so much. Yeah.
Thank you, Mary.
Yes, so that concludes our meeting today. There have been some things in the chat shared, specifically my request if you're interested in the SCOast Analytics Lab training, you have identified a date and you want to get signed up, just shoot me an email. I put my email in the chat. I hope I typed it correctly. We will, just pointing out, we will also be updating our website on this for SCOast Coast on the scoast.org website. I will share a draft of the updates for everybody to kind of take a peek at. If you have content that you would like to be added, or you see a change that needs to be made that somehow we missed when we scanned it, please point that out. We're trying to get those updates made this week, so it's not, we don't have out-of-date information on there. So once again, thank you very much for joining today, and have a great day.
Thank you and bye-bye.
Thank you, Mary Beth. Thank you to all.
Thank you.
Bye-bye.
Bye, everybody.